Good morning to all of you. I am Shravan, Assistant Professor, Department of Computer Science and Engineering, Kumar Engineering College, Ghaziabad. My today topic is dynamic memory allocation. So, first of all, why we need dynamic memory allocation? Dynamic memory allocation is a very important concept in term of data structure as well as C programming. This topic is very essential as well as very important in all aspects. So, why we need that dynamic memory allocation? So, dynamic memory allocation, when we declare a variable or an array of any data type, so the space occupied by them in the system memory remain constant throughout the execution of program. So, sometimes the constant space allocated at the compile time may fall short, and we need to increase the space during the runtime. We come through the concept of dynamic memory allocation. So, allocation and deallocation of the memory at the runtime in C are done using the concept of dynamic memory allocation. Here the concept says, once we are going to declare any variable or an array, that remain the memory allocated in the system will remain same. We can't change it at the runtime. But in the dynamic memory allocation, we can increase or decrease or change the size, the allocated space as per our need. So, it is the method in which we use different library functions. So, these library functions are MALLOC, CALLOC, realloc and free, which are used to allocate and deallocate a memory block during the runtime. So, it is considered as a very, very important topic, because every data structure like linked list, stack, queue, tree is associated with the concept of dynamic memory allocation. So, next, what are the difference between static memory allocation and dynamic memory allocation? The static memory allocation says the constant or invariable memory is reserved at the compile time of our program that can't be modified at the runtime. While in the dynamic memory allocation, the variable, we can say, memory is reserved at runtime of our program can be modified. Second, it is in static memory allocation, it is used at compile time of our program, and it is known as compile time memory allocation, while the dynamic memory allocation is known as runtime memory allocation, because it is used at the runtime of our program. It is also known as runtime memory allocation. We in static memory allocation, we cannot allocate or deallocate a memory block during the runtime, while in dynamic memory allocation, we can allocate or deallocate a memory block during the runtime, and we can change it. In static memory allocation, space is used in will be stack memory, while in dynamic memory allocation, the space is used as heap memory, where the values will be stored. Next, in static memory allocation, it does not provide reusability of memory while the program running, so it is less efficient. Dynamic memory allocation provide reusability of memory while the program is running, so it is more efficient. Next, dynamic memory allocation in C, the definition of dynamic memory allocation is the manual allocation and freeing of memory according to our programming needs. So, dynamic memory is managed and served with a pointer that point to the newly allocated memory space in the area which we called heap memory. So, heap memory contain in either object memory or pointer memory or dynamic memory, where we are going to store our variables. So, the function we used for dynamic memory allocations are MALLOC, CALLOC, realloc and free are part of stdlib.h library functions. So that library, the stdlib.h, will contain all the functions of dynamic memory allocation. In next slides, we will discuss about these functions, their purpose, their syntax, and we also discuss about their examples. So here, first function we use from stdlib is MALLOC. MALLOC means allocating the memory of requested size and return the pointer to the first byte allocated space, which means we are going to allocate memory. The syntax for MALLOC is void next pointer type of MALLOC in size of t. Now how we write it? We write is int star pointer type, and the pointer type, as we know, this is a void type, so any kind of data type can be used. So pointer type can be of integer type, it can be converted to integer. So integer type of pointer MALLOC. Next we are going to specify the size and size of that type of variable. So we are using integer, so we take integer of size of int. If we are using older type of computer where less than 32 bit of computer, in that case the size of int will be 2 byte. For new type of computers, the size of int will be 4 byte. So how much it will allocate? It will allocate 50. If I take new type of computer in recent days, so it will take 50 into 4, which means 200 byte of for allocating this pointer variable. Fine. Next, second is CALLOC. So CALLOC means contiguous memory allocation. CALLOC means contiguous memory allocation. So it allocates the space for element of array, initialize the element to 0 and return a pointer to the memory. The syntax is almost same. The difference is here we are using the size of that variable, and here what we are using? Void. Same as we are using MALLOC, it is here using CALLOC. Size t and number of item, that is comma operator. Here we are using comma operator, and size t, size of t. So that remains same. Here the memory location will be 50 and which means 50 memory 50 bytes 50 size 50 space of 4 byte of memory if we are using new type of computer. Third function is realloc. Realloc means reallocating the memory space. If we use to modify the size of previously allocated memory, we use realloc. Realloc means the syntax realloc will be void, pointer type of realloc, void, older block size and new block size. Fine. Here the example will be integer star pa, reallocate pa with size of int into n. Next, new size of memory will be allocated. If I talk about free means whatever we are going to allocate, we want to deallocate. For that we are using free type of pointer. Important concept is no star, or we can say indirection operator, will be used in the free function. Here we use syntax will use this thing, but once we are going to use free, we will define the pointer name, it automatically deallocate the memory space. As we know, C does not have automatic garbage collection. So if we are allocating any space or memory, it is our duty to deallocate that thing. So we are going for deallocation, we use free. Now we discuss all these functions in detail. First we are talking about malloc. So malloc in C function, in C it stands for memory allocation. What means memory allocation? That is meaning of malloc. Definition of malloc, that is memory allocation. It is a function which is used to allocate block of memory dynamically, and it reserves memory space to specify size and return a null pointer to the memory location. If it is not used, it will automatically return null. So the pointer return usually of type void, so which means we can assign C malloc function to any pointer. As we are using here, we have used integer type of function, fine. Integer type of variable. So same we are using syntax here: pointer name, pointer type, casting type of that with indirection operator, malloc, size of byte. Here ptr is the pointer of cast type. So the C malloc function return a pointer to the allocated memory of byte size. So how we use pointer, integer star malloc and 50, which means 50 into 4 means 200 bytes of memory will be allocated. Same we are using earlier. So one important thing, when this statement is successfully executed, a memory space of 50 bytes is reserved. So the address of first byte is reserved, space is assigned to pointer of type int. So this how we are using this malloc in our program. See here, first of all, hash include stdlib.h int main, we are using pointer variable, pointer equal to malloc, next 15 memory as allocated of size ptr, that is of integer type. See this thing, that is multiplied. So a block of 15 integer of integer type. Here we are going to checking for pointer type. If it is not null, in that case we are assigning pointer plus 5 equal to 480. So the assigned 480 to the sixth integer, because pointer is 0 up to 5. So sixth integer will be 480. The value of sixth variable will be 480. So we are going to print that thing. Here the output will be 480. Output will be 480 for sixth integer. So notice in this program, the size of ptr was used instead of size of int. So it is in order to make code more robust when star ptr declaration is typecast to a different data type later. We can change it later on. So the allocation may fail if memory is not sufficient. In that case, it return null pointer. So we must include the code to check for null pointer. Here we have check for null pointer. So keep in mind that allocated memory is contiguous, so it can be treated as an array. So we can use pointer arithmetic to access the array element rather than using bracket. So we advise to use of plus arithmetic operator to refer to array element, because using incrementation plus plus or plus equal change the address stored by the pointer. One important thing, malloc function can also be used with the character data type as well as complex data type such as structure, union, etc. Next, we are talking about CALLOC function. So, CALLOC function stands for contiguous memory allocation. MALLOC for memory allocation, CALLOC for contiguous memory allocation. So, this function is used to allocate multiple blocks of memory. So, it is dynamic memory allocation function which is used to allocate the memory to complex data structures such as array and structure also. MALLOC function is used to allocate single block of memory space, while CALLOC in C is used to allocate multiple block of memory space. That is the major difference between CALLOC and MALLOC. Next, each block allocated by CALLOC function is of same size. That means if we are using 15 values, it will take same size of memory, which means same size of memory will be used in the memory. So, the above statement is used to allocate n block of memory of same size. After the memory space is allocated, then all the byte initialized to 0, while in malloc all the block initialized to null value. Here it is initialized to 0. So, the pointer which is currently at the first byte of the allocated memory space is returned. So, whenever an error allocating memory space such the shortage of memory, then the return pointer then the null pointer is returned. So, in this CALLOC function program, here we see we have taken integer I, first variable, pointer type variable, and sum equal to 0. Same ptr equal to CALLOC 10 size of int, means 10 memory location are allocated of size int, means same int type of 10 allocations are there. Here also we check for null, if pointer is equal to null, in that case memory is not allocated and exit 0 and program will be exit. Otherwise, we are building and calculating the sequence sum of the first 10 element. So, for that we are using loop. Loop will be starting from 0 up to 10 plus plus I, and for each pointer variable ptr plus I equal to I, and sum of these value will be assigned to sum, because sum equal to 0. So, we are going to print that sum, and after that, after the work is done with CALLOC, we are going to free that pointer and return 0, because we are using int. So, after building and calculating the sequence of the first 10 terms, the sum will be 45. Sum will be 45 because it is taking 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So, the sum of all these terms will be 40. 45. Next, realloc. Reallocate means reallocation of memory. So, using C realloc function, we can add more memory size to already allocated space, or we can also decrease the memory space. So, it expand the current block while leaving the original content as it is. So, realloc in C stand for reallocation of memory. So realloc can also be used to increase or reduce the size of previously allocated memory. So the syntax for realloc function is ptr equal to realloc previous pointer size with new size. It will automatically increase or decrease. So the above statement allocate new memory space which is specified size the variable new size. After executing the function, the pointer will be returned to the first byte of the memory block. So the new size will be can be of larger or smaller than the previous memory. So we cannot be sure that if the newly allocated block will point to the same location as that was the previous memory block, or this function will copy all the previous data in the new region. So it makes sure that data will remain safe. That is internal matter, that is not our concern. So how we are using the reloc function in C program. Here we see hash include stdi.h integer main, we are using character type of pointer. So ptr equal to character type of pointer malloc 10. Earlier the value of the malloc the value will be assigned 10 variable 10 byte. So we are using this word programming to this string to the ptr, and the ptr will having 0 1 2 3 4 5 6 7 8 9 10. The value is 10 values are there. So value will be ptr having programming with 10 variables. Now we are going to print that variable. So we have printing that variable. After the printing, we are going to reallocate the new size we are going to provide is 20. After the 20 is going to be given, so we can again using the string cat function, means string concatenation function, where the ptr can hold these four variables also. 1 2 3 4 5 6 variables, 6 string 6 characters also. So after that we are going to print that thing. So ptr. So first it will give the value, and second will be the size. So whenever the realloc in C result in an unsuccessful operation, it return a null pointer and the previous data is also freed. Last one is free function. So free function in C, the memory for variable is automatically deallocated at the compile time. In dynamic memory allocation, we have to deallocate memory explicitly. If not done, we may encounter out of memory error. So for that, the free function is called to release or deallocate memory in C. So by freeing memory in our program, we can make more available for use later. So here what we are earlier we also use the free function here also. So for that purpose we have created this free a program for allocation deallocation. So see here in this we have used stdi.lib.h, then we have defined the main. After in this main we are allocating the memory using malloc with 10 size 10 byte of 4 of that integer type. Next, if pointer is not equal to null, the pointer plus 2 equal to 50. Third variable, second integer value will be given. After that we are going to free that, and the value of second variable will be 50. After that the value will be freed. So let us recap or relook all the functions once again. So if in examination there is a difference between dynamic memory allocation, difference between all these functions is come, then we have to make this table and we have to define it. First, in malloc, allocated single block of specified memory and return address of it, while in calloc, allocated multiple block of specified memory and return address to it, while in free, to deallocate the memory wherever the allocated using malloc, calloc or realloc, while in realloc, reallocating memory if previously allocated memory is not sufficient. The syntax for malloc is void malloc size t of size, while in calloc void star calloc size t n size of t, while the free void ptr star ptr. For realloc void realloc ptr comma new size. Malloc, it return starting address of allocated memory on successful allocation, otherwise it will return null, while calloc return address of allocated memory on successful allocation, otherwise it will return null. Free, it reduce the waste of memory after freeing it, while realloc return the pointer to the new allocated memory on successful allocation, otherwise it will return null. In malloc, it does not initialize the allocated memory space. It will remain, the note allocation will be there, while in calloc, it will initialize the allocated memory with 0, while in free, the free is being used whenever dynamic memory allocation take place and we don't need that thing, while realloc, it does not initialize the allocated memory. So last point is for malloc we use ptr equal to data type of that pointer malloc size of byte, while calloc the n is the number of block, size byte is size of each block. In free, if null pointer passed as argument, it would not you to do anything, while in realloc ptr equal to data type realloc n into size of byte. Thank you very much.